I'm here again. Now, my name still remains Mr. Toby, and for identification reasons. Now, we actually ended fundamental quantities and derived quantities. And now we are going towards scalar and vector quantities. I want you, if you have any question to ask on fundamental and derived quantities, please do me a very big favor by chatting me up or sending me any question on that topic that we just dropped. Now, we are going to be looking at scalar and vector quantities. Something beautiful about these scalar and vector quantities, furthermore student, you are still going to meet something like this. So, we are going to be looking at just the scratch of scalar and vector quantities. It's one of the classification of what? Physical quantities. Now, for scalar quantities, we say that what? Scalar quantities are quantities that has magnitude but no direction. Can be defined as quantities that has magnitude but what? No direction. Meaning, now when you're talking about scalar quantities, we're going to be looking at some examples. Now, scalar quantities has magnitude but no direction. Now, don't look at the big word magnitude. Magnitude means what? Numeric value. Magnitude means what? Numeric value. Now, if you have a mass of a body, a mass of a body is 50 kg. Now, this 50 there means what? Magnitude. When we talk about magnitude, this 50 here means magnitude. So if I actually ask you, how old are you? You tell me a particular number. That number that you have given me is what we call magnitude. Are you with me? So now, it has no direction. Now, direction here in physics is not talking about moving sideways or left, right, down, center. It means your north, south, west, and east. So when you're talking about mass of a body, you can say mass of a body is 50 kg northward. It doesn't make any sense. It has magnitude but no direction. So whenever you are illustrating it, it only has magnitude but no direction. So therefore, for my example, mass is one of them. We have what? We have time as one of them too. We have what? Temperature. Now let me give you a very small example. Now, all fundamental quantities are scalar quantities. They have magnitude, but they don't have direction. Now, let me write it down. All fundamental quantities are scalar quantities. Just note that. Now, we're going to move into what? Vector quantity. Now, when we talk about vector quantities, we talk about what can be defined as quantities that has magnitude and also what? And also direction. It has magnitude and direction. And we have example, e.g., displacement. Now, when you talk about displacement, I wouldn't go deep in it because it's actually a foundational or basic class. We're still going to touch displacement. Now, when you talk about displacement, you want to talk about displacement of a body moving or changing a position in a specified direction. That's the difference between displacement and distance. I can tell you that what I want to take a walk. I want to make a distance. When you say that you are going a distance, you don't have anywhere you are going to. You guys call it what? Strolling. You want to stroll. When you are strolling, you want to take a distance. So a distance doesn't have direction. That's why it falls under what? Scalar quantity. Why for displacement it falls under what? Vector quantity. It has direction. Now for displacement we have several other of them. We have velocity. We have acceleration. We have force. Now, when you look at force, if you apply a force, you know that what the application of that force leads a direction. When you apply a force, it's changing a position of a body with what? Acceleration. That's why we say that what our force is equals to what? MA. I wouldn't go deep into that. When we actually get to what? The dynamic aspect of mechanics, then you understand better. Under what? The second Newton law of motion. You understand this better. But for now, students, I want you all to write down different examples of scalar quantities and vector quantities. I actually leave you with this, and you can also send your question so that I can answer it all. Take care of yourself. Bye.